All right, hello, Aubrey. This is section 2, 7 notes. This is only one-sided, so this is kind of exciting. There's only one really tricky part to this example, or to these notes, and it's example 1. So after that, it gets a little bit easier. 2-7 is solving equations. I'm going to talk about this first example. You got to listen. I want to talk about this first example, and then we're going to graph it down below, okay? The height of a punted football can be modeled by this function right here. The graph of the function can tell you how high the ball is during its rise and fall and when it hits the ground, all right? So this function, what is his parent function, by the way?
Y equals x.
Y equals x squared is the highest power. Now, the plus x gets trumped by the x squared, so this is just an x squared function. We haven't seen these yet. We did in chapter 0. Put that tape away. We saw these in chapter 0, but this is a parabola. This is an x squared function, okay? So, and one more thing about this x squared function. It is facing down. If it's a negative x squared, that means it is a frowny face, okay? So I'm going to draw a frowny face at the top of the paper. And what this is going to look like, you can do a frowny face. You can, really good. That's a really good parabola right there. Look at her parabola frowny face. Look at her parabolic frowny face. I can't even do it. I can't even do it. Look at that. I love it. I love it.
I love it.
There we go. Perfect. Okay, so this is the graph of a parabola. That's a frowny face. Notice that I put it in the first quadrant because when we're punting a football, we can't have negative distance or negative time, right? So in this, well, yes, technically, but that's a different thing. And actually, okay, so I like what you just said there. That would be, okay, so Jack, that would be if this x direction was representing the horizontal distance, right? Horizontal distance, okay? And you're saying, yes, you could have back here, that would be back behind the line of scrimmage, but this x is not representing horizontal distance, it is representing time. So now we're not even taking horizontal distance into consideration, we're just doing time. This y-axis does, however, represent the height of the ball. So it's height of the ball with respect to time, not height of the ball with respect to horizontal distance. Make sense? Okay? So you can't have negative time. So yes, you are true. You are true that if it could go back negative, and that would be if we were doing horizontal distance. So good point. All right. There you go. So we have this going on here, and this is like me touching the ball, and it goes up and then it comes back down. Okay. Now what we're looking at in this chapter, or in this section, is these points right here, and these are called x-intercepts. We know that, right? Like you guys just had a quiz, and it asks for the x-intercepts, or do you remember what they called them? The zeros, right? The x-intercepts or zeros, that's what that means. We're trying to find those places because those tell me where the ball is at ground level, yeah? Okay, so let's go on in example 1 and let's talk about finding the x and y intercepts, okay? So here's what I want to be able to do. I want to be able to take this function and before I graph it, find the x and y intercepts, and you can do it very easily, okay? Let's talk about x-intercepts over here, and let's talk about y-intercepts over here, okay? We're going to find them using some algebra stuff, and then we're going to use that to graph the function rather than vice versa. We are not going to graph first, okay? So let's talk about x-intercepts real quick, and I'm going to graph you what some x-intercepts look like, and we're going to look at a trend, all right? So x-intercepts, here's an example of an x-intercept. Let's say that is at 2, 0, right? Let's say here's another x-intercept that is at 5, 0. Let's say here's another x-intercept that's at negative 3, 0. Those are all x-intercepts. What do they have in common? They have a 0 as the y coordinate, right? The y coordinate is 0. So here's what you do. If you are trying to find the x-intercepts, you plug 0 in for y. You plug 0 in for the y coordinate. That's what you do. So what we're going to do here in a second is we're going to plug 0 in for y, and when I do that, I will end up with 0 equals 1/2 x squared plus 1/2 x minus 6, right? I plug 0 in for the y coordinate, okay? Yes. And we're going to solve that here in a second, but we're going to do the y-intercept first because that's easier, okay? Can we skip to the easy one first? Get our feet wet, right? Okay, let's talk about y-intercepts. So over here, y-intercepts. Here is an example of a y-intercept. Let's say that's 0, 2. And here is 0, 7. And here is 0, -4. And what do all those y-intercepts have in common? 0 is the x-coordinate. So it must be true that if I'm trying to find a y-intercept, I plug 0 in for x, right? I just plug 0 in for the opposite one, and that's how I find the y-coordinate, all right? So let's do that one first, because that one's a little bit easier. So y is just going to stay by itself, right? But I plug 0 in for all the x's. So 0 squared plus 1/2 times 0 minus 6. I'm plugging 0 in for the x's. Does this make sense? Are we doing okay? All right? Now, if I take 0 and square it, it's 0. What's 1/2 times 0? Boop. 1/2 times 0?
Nothing.
Boop. So the y-intercept is?
-6.
-6. Now, that's always the way that it works. Okay? You can do the y-intercept without actually having to look at the function, because anything that has an x is going to go away, because anything that has an x is going to become 0, right? So your y-intercept will always be that single number on the end. Did you know that? Your y-intercept will always be that 6 or that single number on the end. Everything else will cancel out because it's 0, right? Okay? So if I graph y equals -6, that is that y-intercept down there. We're looking for that, okay? So we've got that ready to go, okay? All right, everybody take a deep breath. This is kind of the hard part. All right, here we go. We got to solve for the x-intercept, which we said we plug 0 in for y, right? I have, are you ready? 1, 2, 3, 4 pieces, and some of them involve fractions, and we hate fractions. So we're going to get rid of them, right? How do I get rid of a 1/2? Yeah, let's take it times 2, I heard some people say, right? Let's take the whole thing times 2. So 2 and 2 and 2 and 2. We're going to distribute the 2 through, all right? What is 2 times 0? 0. What is 2 times 1/2? Just 1. So I'm going to write it as just x squared, because that number in front is a 1, right? What's 2 times 1/2 x? Just plus x, right? 1x, right? And what's 2 times -6? -12, okay? All right, so now he looks a lot nicer than he did before. All right? Now, we still have to solve him, though. So what I want to do is I want to break him down. And I can break him down because this is a simple trinomial. We got to think way back to chapter 0, right? Simple trinomial. So I am multiplying to get -12. But when I add them, give me this number. What is that number, by the way? 1. So what can I multiply to get -12, but when I add them, give me 1? -3 and +4. So I write it like that, right? You remember doing that? X minus 3 and x plus 4. -3 times -4 will give me -12, but -3 plus 4 is 1. Yes, that works. Okay, good. That's broken down. One more step to finding the x-intercepts. I'm going to take each one of those pieces. I'm going to say x minus 3 equals 0. And if x minus 3 equals 0 and I'm solving for x, I would add the 3 to the other side. So x would then be equal to +3, right? Okay? Now I'm going to do the same thing for 4. If x plus 4 is equal to 0, and I subtract the 4, x will be equal to -4. So I have 3 and -4 are my answers. What were those again? The zeros, or the x-intercepts, right? Okay. So I have 3 here and -4 here, and we know this thing looks like, have we established that it looks like a parabola? The parent function of this guy is still an x squared. Is he a smiley face or a frowny face?
Smile.
How do you know he smiles?
Because there's no negative.
Because there's no negative right here. The 1/2 is a +1/2, so he's going to smile, all right? So there's this, and we have those dots, and he's going to smile, right? He's going to come down like this. And it's worth mentioning, whoa, that looks really awful. It's worth mentioning that this -6 down below here is not the lowest point. Do you know how I know it's not the lowest point?
Because it's not in the middle.
It's not in the middle, right? Like -4 and 3, like -6, this one down here would not be in the middle. Right here would be in the middle, so the lowest point's going to be about there, yeah? Okay, so it actually hits that point on the way back up. But we'll discuss more of that in chapter 3, okay? Chapter 3, we really start talking about parabolas, okay? Good? Yes? All right, that was the hardest problem. it gets easier from here, okay? Because then this next one, they have us do a linear function, all right? Now, the y-intercept is typically the easiest one to find. This guy is pretty easy, right? It was the easiest one to locate. But in order of importance, the x-intercept is actually really important. This tells me information about like what I'm wanting to know. Like that's when it hits ground level usually when I have a parabola, right? The x-intercept is really what I'm wanting to find, okay? The y-intercept is the easy part to find, but the important part to find is a little bit harder, okay? Now, the x-intercept is so important that he has multiple names. We already know one of his names, and x-intercept is also called a 0, but sometimes they are also called roots, or they are called solutions. So any one of those 4 names are meaning the same thing. If it's called a solution, or a root, or a 0, or an x-intercept, they are talking about the x-intercepts. They're talking about those zeros, okay? So down here they say roots. Find the root of the linear equation, okay? That just means find the 0. That's what they're talking about, okay? Of this linear equation. So I have this guy right here, negative 2x plus 10, and I'm wanting to find the root, which is the x-intercept. Now I'm going to change the instructions, and we're going to find the y-intercept also, okay? I can look at that thing right now and tell you what the y-intercept is. Do you remember the trick?
Yeah.
What is the y-intercept? 10. You're plugging 0 in for x. So that's going to go away, and your y-intercept is 10. It's just always that number that's at the very end. My y-intercept is 10. So I'm going to put a dot on the y-intercept right there. Okay? Remember that. The y-intercept is just that last number. Always. That's your y-intercept. Okay? Now, to find the x-intercept, I plug 0 in for y. Okay? So I'm going to plug, and f of x is the same thing as y, so I'm going to solve that thing, right? 0 equals negative 2x plus 10. I'm going to solve this to find what the x-intercept is, okay? Now, what are you going to do first?
Subtract 10.
Subtract 10. That would be a good idea. Okay, he's gone. So I have negative 10 equals negative 2x. And then what?
Divide by negative.
Divide by negative 2. What is negative 10 divided by negative 2? Positive 5. So the x-intercept is positive 5. That was pretty easy to solve. That wasn't as hard as solving this one up here. How's come that wasn't as hard? Because it's a linear function. This is a line. This is linear. If it's a quadratic function, it's a little bit harder. That's when the x-intercepts get icky, okay? But when it's a linear function, it's not really hard. So I know that he's touching here at 5. 1, 2, 3, 4. I think that's at 5 right there, okay? All right, so there's my 2 dots, and we know this is a line, so we know we have to draw a line between these 2, right? Mm-hmm. But before we draw a line between these 2, let's go back to like how we normally graph a linear function, right? So we would start at 10, right? And we would go down 2 over 1, because that's the slope, right? Down 2 over 1, down 2 over 1, down 2 over 1, down 2. Ooh. He's going to hit at 5, right? So we did it exactly right.
Anyone who money for basketball, that must be paid by Monday morning at 8 o'clock in order to receive a shirt. It's been requested that there's a pink out for tomorrow, or for tonight's football game. Junior high girls basketball practice will start on Monday. That's for anyone interested in playing or student managing. Practice will be done by 5:30.
Gordon, be nice.
Also, beginning next week, the weight room will be open after school on Mondays, Wednesdays, and Fridays.
Once we get done with this problem, can I go run and grab something?
Yes, yes, yes. Okay. All right, good. Does that make sense? As a linear function, x and y intercepts.
Yeah.
Good. Okay, this next one. Graph the function from the punting example. The punting example was y equals negative 16x squared plus 10x plus 2. That's what it was up above, right? Now, this one is a little bit uglier to graph. It's not a simple trinomial that we can just solve for the x-intercepts and be done for the day, right? So what I'm going to do is I'm going to cheat. We will in chapter 3 learn how to graph this, like not by cheating, okay? But for now I'm going to cheat, and I'm going to go to Desmos, which is my handy dandy graphing calculator online, and I'm going to type it in. Negative 16x squared plus 10x, whoa, back, 10x plus 2, okay? Here's what my function looks like when I graph it. We're going to graph it on your paper, okay? Now, it's intersecting here at 2. Do you see this intersection here at 2? The y-intercept is 2. the y-intercept here is 2. It goes up to about a little over 3.5. Goes up to a little over 3.5, and then it comes back down here to like 0.75 something. Right? You see? 0, and this is 1, this is 0.75, okay? So let's graph some of that stuff on example 3. Here we go. You ready? I'm going to change the coordinates on example 3, and we're going to do this. I'm going to say that this is 4. Halfway is going to be 2. This is 1, and this is 3. And I'm going to put 1 here also. And 2. And 3. Okay, so I'm just going to like make him go like that, where he's a little bit wider units. Okay? Now, the y-intercept was at 2, right? We know that from like the function. The y-intercept is 2, that number. Why is it intersecting at 2? We're talking about punting the ball. Why doesn't it start at 0 down here?
Because you start on a 0.
What?
Because
The
it
ball is
starts
not-
up.
The ball is not doing something before.
Ah, well, kind of. You're on the right track. When you're punting the ball, when you're kicking off, you kick the ball from ground level, right? Like it's on a little stand and you kick it, right? But when you're punting the ball, I know it's hard. I don't know this information either. I had to be told this at one point. Okay. So when you're punting the ball, you drop the ball and you kick it like this. And what they're saying is the ball starts moving 2 feet in the air, which is where it connects to my foot. Right? My foot was 2 feet in the air when I touched the ball. All right. It's coming back down and hitting here at about 0.75-ish. This is about 0.75. Okay? And in the middle, it reaches up here at about 3.5. So it's going up, and then it's coming back down. Like that. That's my parabola. Okay? Now, what is the x-axis representing?
This is horrible.
Time. Okay? And what's the y-axis represent? The height. Okay? So it says, what do this, where is the 0? Where is the 0? At about 0.75, according to the graph that I just graphed on Desmos. It's about 0.75. What does 0.75 mean?
Yes. When the ball, 0 for the ball.
That's the x-intercept. Well, what does that mean?
When it touches the ground.
When it touches the ground. The time that it touches the ground. So, the ball is in the air for 0.75 seconds. That's a really quick ball going through. It's probably just like it's not a very big kick, right? Not a very big kick. It's only in the air for 0.75 seconds, okay? So that's why we might be interested in x-intercepts. All right, I'm going to give you your homework assignment. And I'm going to leave this up here. Skills practice is evens. The other side is all. Here you go. Skills practice is evens. The other side is all.
Yeah, we should wait until Monday for us to actually start working on this.
Can I?
Well, because it's Friday and we are tired.
And you're tired, I
And we
know.
can. It's like
Me too.
this. I'm not sure if I can do homework. Can do.
I'm sorry.
Can I
Yeah, I
go
can't do
grab
homework either.
my bag?
Now hold on, don't put this away yet because I gotta talk about one thing that always confuses people.
Monday?
Skills practice is evens. The other side is all, yeah?
I should write that down.
Skills practice is, unless you wanna do all on both sides, I don't care. But skills practice is evens, practice is all, yeah?
Wait, practice is all.
Practice is all, skills practice is evens. Okay, I made you so you don't have to do a story problem. All right, now, real quick, before you put it away,
What is
Putting it away.
take a look at 4, 5, and 6.
Yes.
4, 5, and 6 have the same instructions as 1, 2, and 3, but for some stupid reason, they went ahead and plugged 0 in for the y. So, on 4, 5, and 6, just pretend that that 0 is y, because that's what it's supposed to be.
Okay.
4, 5, well, yeah, but on the other side too. On the other side, 4, 5, and 6 on the other side as well. Should just be y instead of 0.
So we're doing 2, 4, 6.
Well,
on
my
skills
stuff's away.
practice.
So.
Correct, correct. Okay, but any of the 4, 5, 6 problems that, for some reason, they just already plugged the 0 in for y for you. I don't know why they did that, okay? But just pretend that that says y because that's what they mean for it to be. Okay, good? All right.